Okay, so item one that I do know. This is new information. This is much newer than you've seen before. Agree? Now, I'm going to show you a way to be breaking these down once we start working with work today. That if you trust me, I can get you through it. Okay? And I think some of you trust me. But what kind of questions did you want to take a look at on page 127? What could I help you with? What did you see that gave you a struggle or two? Yeah, Mike.
Give me 21.
21, you got it. Good one to ask about. 21. So we have. Okay, so before I start this problem, one thing I want you to notice. The base, the bottom, the negative 27, is in parentheses. Agree? That's a big thing to know when you're doing these. If it's grouped together, that means that root 27 has to be underneath the radical. Okay? So I want to write this as a radical. Okay, so far, are you okay with that? Everyone follow where the numbers went? So remember, the bottom number here goes into this little thing here. And then, do I have to put 27 to the first power? No, it's not necessary. I mean, theoretically, the 1 is right there. That's where everything broke down. So the 1 comes here. You don't necessarily have to put it, the 3 goes there. Okay? So things that we have to think about. Let's think about it this way. Would you agree that 27 is, and I know it's going to be, I'm going to have 3 negatives that I'm going to use. Okay? Is that okay so far? Because it's, all right, now, 27 is the same thing as 9 times 3. Do you agree with that? Can I break 9 down? Yeah, so I get 3 times 3 times 3. Okay? So it's negative 3 times negative 3 times negative 3. Now, the reason I'm kind of slowing this a little bit is I want you to see something. How many negative 3's do I have sitting underneath that radical sign? I have 3 of them, right? And I'm taking the third root. Agreed? Does that make sense? So if I'm taking the third root, that means I'm looking for 3 of a kinds. Okay? So a big thing to note is that, oops, I didn't want that, I want this. This right here means I'm looking for 3 of a kind. Do I have 3 of a kind underneath the radical? I do. So the third root of negative 27 is negative 3, and it's done. Now, that kind of looks weird because you're like, wait a minute. I didn't think I could take the square root of a negative number. You're right. I'm not taking the square root, though. I'm taking the third root. So if this number here is an odd number, so if it's third root or fifth root or seventh root or ninth root, and don't worry, you're not going to see fifth root, seventh root, ninth root. If I could do that, I am allowed to have a negative underneath, and it does come out to be a number, and we wanted to say, is this an integer? And that is indeed an integer. Okay? And then rewrite the expression as radical. We did that. Classify it is an integer. Remember, integers are positive, negative numbers. And then calculate. Now, the thing is, it says use a calculator. Now, I know a lot of you might not have a calculator with you. Can you do me a favor? Can you try and see if you can find a cheap calculator and just start putting it in your bag just so you have it? It doesn't have to be one of the big fancy graphing calculators. You don't need that. I bet you there is a calculator someplace in your house. And I'm just going to make a thought where you might find this calculator if you're like, I'm not sure where to find it. Okay, somewhere in your kitchen, you still following me on this story? There's going to be a drawer. And inside that drawer is the catch-all. You open the drawer, there's a couple of batteries in there that might or might not work. There might be a stapler that hasn't worked since 1974, but we're going to hold on to it. A couple pairs of scissors, some rubber bands, some twisty ties, and then in the back, this calculator. Little cheap one. Agree? You know the drawer I'm talking about? That might be a good place. If you can't figure out where one's at, that might be a good place to say, let me check that drawer. Because I think most Homes USA have the catch-all drawer somewhere in their kitchen. You just throw stuff in there. I mean, I know it's like, oh my gosh, I need find a screw that's a 1/2 inch long, that is threaded for oak. Open the door. It's right here. Like, why is it that? I don't know. It like seems to just grab stuff. So it'd be really, really, really beneficial if you could find yourself a really inexpensive calculator. I know a lot of times you go into Target in that dollar aisle right when you walk in. A lot of times they have cheap calculators for $1. Go see if you can snag one, please. What other questions could I help you with off the homework? Yeah.
Number 19.
19. Good one. Good one. I like it. Okay, so number 19, we have this. Okay. So first thing I want to do is I want to rewrite it. It says rewrite it as a radical if necessary. It's already a radical, right? So things that I have to know. If I don't have a 2 here, there's a 2 there. It means square root. That's the one thing to know about. Okay. If I have square root, 4th root, 6th root, 8th root, which those are even roots, I can't have a negative under the radical sign. Okay? So this automatically says this is a non-real number. And that's all you'd have to do. You don't have to go any further. But you have to be able to recognize, do I have an even root? Now, we'll deal with probably square roots and third roots. That's probably the only, so one's even, one's odd. If it's third root, it could be a positive or a negative number, or if it's a square root, it has to be positive to work. Okay? Yeah?
And can you also tell that's a non-real number because like there's no square that goes into anything?
Yeah, there's no two identical numbers that I could multiply together to get negative 24. Okay? Anything else I could help you with on that? You okay? Can I go to the notes? Is that okay? For those of you who didn't get it finished, make sure you get it finished. Show me tomorrow. If you're absent, make sure you have it done next time you come to class. That way, give you full points. If you didn't have it done today and you were here yesterday, you can earn the 2 out of the 4 points on it. Okay? But if you would turn to page, I believe it's 129. Let's see, where are we going? Is that the first part of yours? Okay. So I want to think about this for a minute. I think most of us could probably look at square root of 16 and say the answer is 4. Agree? Does that make sense? But let's investigate this a little bit further of why we could say that the square root of 16 is equal to 4. So one thing that I want to build upon a little bit is, do you agree that square root 4 times square root 4, so I'm not worried about the radical, but do you agree that 4 times 4 is 16? Okay? So that means square root 4 times square root 4 is square root 16. Okay? So being I am looking for, let me change this a smidge. I'm going to change this, put it as under just one radical sign. Being that this is a square root means I'm looking for 2 of a kind. I'm looking for a pair. Okay? Now, if you broke 16 down to 8 times 2, is 8 or is 2 a perfect square? The answer is no. So the answer to this just comes out to be 4. Well, with that known, I know that 100 is square root 10 times square root 10. because 10 times 10 is 100. So again, it's a square root, so I'm looking for a pair. So square root 10 is just 10. Okay, and I realize that that's stuff you've seen before. You kind of have that as your go-to. We're going to get to a point today where it's not going to break down as easily. Let's see. So you have square root 300 down here. Agree? Okay. So I know on your sheet there, it has a list of the perfect squares. Now notice I'm not starting with 0 and they're not starting with 1. 0 times 0 is 0. 1 times 1 is 1. But what I want to do is this. I want to think about 300 in my perfect squares that they have listed. It looks like they go up to 144 on the perfect squares they have listed. Okay. Is there a way I could break down 300 where one of the numbers is the largest perfect square? Like what would, if I said, what times what would give you 300, and you can't use 1? What would you say would make 300? 15? Okay. Something else? 30 times 10, I like it. Okay. 6 times 50, good. Go bigger. How much? 150 and 2, I like it. Go a little smaller than 150. How much? 100, yeah. Okay, now, the reason I kind of wasn't writing everything down, though you were telling me all these correct things that multiply together, that would get you 300. If I go 3 times 100, what is special about 100? Is it perfect square? So 100 is a perfect square. So theoretically, I could take this and I could say square root 100 times square root 3. Agree? Because 3 times 100 is 300. Now I just broke apart the radicals. What is the square root of 100? 10. So then I get an answer of 10 square root 300, or 10 square root 3, excuse me. So square root 300 can break down to 10 root 3. And this is actually a really good skill, especially when you start 2 years from now, when you get into taking Algebra 2. Okay? Because we start going through these a lot more. But these again, we're trying to take some baby steps. So I want you to always feel comfortable to pause me if you're not sure how something happened. Do I have your word? You'll do that for me? Is there any questions about this page? Are we okay? May I move on? Okay, those are perfect squares. All right. Oh, we just did that one. Just did that one. We are now there. Okay. So does everyone kind of know, like, I could say you need to have this memorized. Great. Joy. It's not going to happen. Half of you won't memorize it, which makes you normal. But does everyone know how to get 4? You know that's 2 times 2, and then 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8. Does that make sense? We good? All right, so square root 48. Is 48 anywhere on this list? Is 48 kind of close to something? It's close to 49. Does everyone agree that 48 is somewhere between 36 and 49? Okay, so I'm going to start. So 48 is going to fall somewhere. I'll draw a little line here. 48 is going to fall somewhere here. Is that okay? All right, so I want to take our time. I want us to think about it. And this is why I want you to have a calculator with you. So some of these you could probably do kind of logically. 49 is not going to work because it's bigger. 49 times some number is not going to give me 48. Agree? Okay, what about 36? Can I go 36 times something to get 48? 36 times a whole number?
No.
36 times 1 is 36. 36 times 2 is 72. That's not going to work. Agree? Ooh, 16? So that doesn't work. 25 isn't going to work because if I go 25 times 2, I get 50. But then 16 is going to work. Now, here's a problem. Notice what I did. I started about where on my perfect squares, about where 48 would be, and I moved up. Okay? Here's the key if you do this. I'm moving up. I'm going from, I know that's not going to work, that's not going to work, that's not going to work. I found something that's going to work. If I started from the top, this one also works. Okay? 4 times 12 is 48, which is good. Bless you. You found a perfect square, but you did not find the biggest perfect square. So what you want to do is list those perfect squares and work your way up. If you work your way up, you're going to do this just fine. And what you can do on your calculator is you're basically going 48 divided by 36 gives you a decimal. You don't want that. 48 divided by 25 gives you a decimal. You don't want that. 48 divided by 16, times 3. Okay? You want that. Okay? Hey, friends, I have a question. What is the square root of 16? 4. So 4 square root 3. It's done. And again, what did I do? I looked at my perfect squares up through, I think your list went through 144. And again, if you don't have that list memorized, you can make it work. Okay? I want to collect watches too. It's too much to collect. Appreciate you. But if you do it my way where you're looking at your list, and again, if the list isn't there, just realize this. On your calculator, go 1 times 1, 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16. Make your list. If I give you a test or quiz, which I don't have any planned this week, but the very first thing, and I'll remind you to do this, the very first thing you should do, if you don't see the perfect squares listed, just somewhere on the sheet, list the perfect squares. Okay, it's pretty quick to go 1 times 1, 2 times 2, 3 times 3, if you can't do it quickly. Okay? All right, so using the same mindset, let's walk a little bit further. Okay, so now we have square root 12. So first thing I'm going to do, I have my perfect squares listed. If they're not there, write out your list. So square root 12 is somewhere in here. Agree? So we're going to go from the bottom up. Okay, so let's think about this. Can I go 9 times some whole number to give me 12? No. 9 is not going to work. Can I go 4 times some whole number to give me 12? Yeah, 4 times 3, right? So that means it looks like this. And friends, help me out. What's the square root of 4? 2. So you get 2 square root 3. There's my answer. Okay, we're breaking down things that are big underneath the radical sign. And this is read as 2 root 3. What math is really taking place here? This is technically 2 times square root 3. And it gives you whatever square root 12 is. Square root 12 is an irrational number. Okay, it's a huge decimal, never repeats. Okay, so again, I'm looking at my list. So let's take a look at this next one. Root 72. Talk to me. Where should I put my line? Between what 2 numbers? 64 and what? There you go. 64 and 81. So 72 falls somewhere in here. Agree? All right, and we're going to go with our same question. Can I go 64 times some number, whole number, to get 72? No, so again, I'm working from the bottom of my line up. What about 49 times some number? 49 times 2 is 98, so that's not going to work. What about 36? Yeah, 36 times what? 2. Good. So again, if you do this, it's going to work nicely. So I know that I have 36 times 2. Again, I worked from the bottom. I found where my line is. I worked from my bottom up to get there. Okay? So some of you might be looking up there going, yeah, but Stirrup, 4 works and 9 works. I know, but they're not the biggest perfect squares. That's why I'm starting from the bottom, as low on my list as possible, and moving up. Okay? So what's the square root of 36? 6. So I get 6 square root 2. 6 square root 2 is an equivalent form of root 72. It's broken down. Friends, we feeling okay? I know for some of you I'm going a little slower, but some of you I'm going probably about the right speed. Okay. Oh, okay. Now, take a pause. This has multiple things taking place. Agreed? I don't just have root something. Agreed? Oh, jeez. Okay. So, does everyone agree that this 3 and this 2 are both outside the radical? Does that make sense? So this 3 and this 2 are both outside the radical. Okay. So, let's see. Hang on. So I have this and this. They're both outside the radical. Well, I'm going to think about this. 3 times 2 is 6. Okay. Now, I'm okay so far. Everyone follow the math I just did? Now, you could multiply 2 and 12 together because they're both inside. Or square root is looking for how many of a kind? 2 of a kind. All right. So this 2, I'm going to bring down here. Let's start breaking 12 down. So 12, let's see, 12 falls right in here. Agreed? Okay. Let's see. 9 times, and I'm trying to get to 12. 9 times some whole number, will that give me 12? No. Will 4 times some number give me 12? Okay. Now, technically, I'm looking for 2 of a kinds or perfect squares. Do I have a perfect square somewhere underneath that radical sign? And if so, what's the perfect square? 4 is perfect square. Agree? Is 2 a perfect square? It's not on the list. Is 3 a perfect square? It's not on the list. So when I was saying we're looking for 2 of a kind, technically I could break this 4 down to 2 times 2. Agreed? So I'm going to kind of do this 2 different ways. And I'm not going to do it 2 ways because I want to confuse you. I want to do it 1 way. What's the square root of this? 2. So I get 6 times 2 outside. And then back underneath, multiply back together. I'm going to get this. So that's going to give me an answer of this. Okay? This is our great answer. Now, I want to show another thought process. Okay? So I'm going to take this whole thing and I'm going to write it here. What I'm going to do with the 4 is I'm going to break 4 down to 2 times 2. So how many of a kind was I looking for? 2 of a kind. So I could pick these 2, I could pick those 2, or I could pick those 2. And basically, I'm going to do this. I'm going to say, all right, I know that right there is a perfect square. So what is the square root of 2? Square root of 4, which is 2. So this is going to come out. So that means the 2 comes outside. So I get 6 times 2. I have that left, which is 6. 6 times 2 is 12. So 12 root 6. Yeah, but what's the right way to do it? Well, some of you are going to see this way. And some of you are going to see this way. What's the right way? Whichever one gets you the correct answer. If you do it one way and you get one answer, you do it another way and get a different answer, one of the ways might not have worked. Heck, it might be possible both ways didn't work. So you have to kind of pause yourself. The operations that take place when you multiply, it has to be outside, outside, inside, inside. there's no reason to multiply 2 and 12 together to get 24. You could have, but there's no reason to. And the reason I said there's no reason to is what happens if underneath the radicals become kind of big numbers? Like let's say you have under one of them 125 and then the other one we have 50. I'm not looking for you to multiply 125 and 50 together and break down the perfect squares. That's really kind of goofy math. Can I move off this one? All right, so same thought process. Same exact thought process. What two numbers up there are right now outside the radical? 3 and 4. Negative 3 and 4. That gives me negative 12 outside. Hey, is it okay if I have a negative answer? Sure. That negative didn't fall under the square root sign, so it's okay to have a negative answer. So now, let's break down 12. Let's see. So I have 4, 9, 16, 25, 36. I think I've gone far enough. Okay. 12 falls somewhere in here. So what times what gives me 12? What times what gives me 12? 4 times 3. And now I have this 3 to worry about as well, so I'm going to bring that down. Okay. So now I've kind of broken it into two things. Do I know what the square root of 4 is? 2. Great. This is going to give me a 2. I have a 2 of a kind here, which is basically 9, right? What's the square root of 9? 3. What's the square root of 3 times 3? 3. Okay? So I've kind of answered it 2 different ways. So watch this. Perfect square, agree? That means the 2's coming out. Is that okay? This also forms a perfect square, so that means a 3 is coming out. So everything is now accounted for. So underneath my radical, there's nothing left. But I have a negative 12 times a 2 times a 3. Let's do a little math. Negative 12 times 2, that's negative 24. Is that okay? And then negative 24 times 3 is negative 72. And there's no longer a radical needed. We had perfect squares underneath this. Now, some of you might be looking at this problem going, yeah, but if I multiply 3 and 12 together, I'd get 36. And square root of 36 is 6. You're right. So then you go 6 times 4 times negative 3, and that also gives you negative 72. Okay, so there's different ways of going about it, but you just have to take your time. Don't feel that because the person next to you might be racing through it, that they're doing it correctly. And I know sometimes that's intimidating, especially during a test or quiz. You know, hand out a quiz that I've designed to take 30 minutes and someone gets done in 18 minutes and turns it in. I know there's anxiety right there going, wow, how'd that dude get done already? I barely got my name on the paper. I'm trying to think about what the date is. Are you with me so far, friends? Okay. Then one last thing. We're going to talk about the Pythagorean theorem. Okay? Pythagorean theorem means if you have a triangle that has a 90-degree angle in it, they call this a right triangle, that if I were to take the square of the sides would be equal to the longest side, which is called the hypotenuse squared. Okay? So let's see if we can decipher that. This is my unknown value. So I have a squared. Here's my right angle here, plus 8 squared, agree, equals 10 squared. Let's do the math. Is there any part of that you're not sure about? 8 squared is 64, 10 squared. I don't have any square root signs that are taking place yet, do I? Hey, what should I do to get the a squared all alone? Good. Subtract the 64 from both sides. And again, I'm showing all the steps. I'm going to bring this up over here. So I get a squared is equal to 36 Now, in order to undo a squared, to get it just to be a, what I want to do is I'm going to take the square root of both sides. Friends, do I know the square root is 36? 6. Done. So that side right there should be 6. And I know you've seen the Pythagorean theorem, but I also realize some of you might have seen the Pythagorean theorem for the first time through online learning when we were in COVID, or last year when we saw you half one day and then the other class the next day. Boy. I think the next pandemic comes through, they're going to figure out a different way to do some teaching, because I know there's some did well with it, some did fair with it, and some got really good at Fortnite during it. He knows. He knows. All right, right triangle, agreed? 2 squared, because it's a leg, plus 6 squared, it's a leg, equals c squared. So I'm trying to find my longest side. 2 squared is what? 4. 6 squared is what? Equals c squared. So I get 40 equals c squared. How do I undo c squared just to get to c? What do I do to both sides? Take the square root. So then I have square root 40. So this is where I go back to my perfect squares. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. Where does root 40 fall? Between where? Yeah, right here. So 36 times something, a whole number, give me 40? No. Does 25 times some number give me 40? No. Does 16 times some number give me 40? You're not sure, so you go 40 divided by 16 gives you a decimal. It won't work. Does 9 times some number give me 40? Does 4 times some number give me 40? Yeah, this is going to work. So C is equal to 4 times 10. This is my perfect square. What's the square root of 4? 2. 10 is not a perfect square. 10 is made up of 2 and 5. Neither of those are perfect squares. So my answer is 2 square root 10. Now this is where I always got kind of kooky on this stuff. Okay, I get that 2 square root 10 is bigger than 2. But how is 2 square root 10 bigger than 6? Well, the square root of 10 is 3 point something. 2 times 3 point something is bigger than 6. Okay? All right. Hey, you guys want a lot of homework tonight? All right. Let's do this. Let's do this. I'll sign you page 131, 132. And how about we get a really good, solid try of the odds? Can we do that? Good enough? Phones, make sure you get them. Get your phones, skedaddle. Have a great day. Take care of one another.